Hello teacher, today our group, which consists of me, Tan Xiaohui, Lo Minyi, Chin Xin Xuan, and Chua Xin Ro, will be presenting about our mathematics group project. Now, let us start.
Okay, here's the question. A factory is designing a rectangular container as shown in the figure below with open top, as means without the top, with a total volume of 60 meter cube. The container will be used in the logistic and manufacturing industry for storing components. One side of the rectangular base length is required to be 4 meters long. That means the length is 4 meters. The material of the base costs 8 RMA per square meter, means the length will be cost of 8 RMA. While the material of the side, which means with the width and the height, will be cost of RM2 per square meter. Okay. Now, determine the dimension of the container so that the cost of the material will be minimum. Okay. So here is the total volume. The total volume will be the formula of the total volume is length times height times base, which means 4WH, and is equal to the total volume is 60 meter cube. So we have to make the H will be the subject. So WH is equal to 16 divided by 4, which means 4 meter square. Now is the H, 4 over W meter. Now it's the area. The area is the width times the height, which means 4W equals to 4W meters square. Now it's the area of the four side. You have to times 2 times 2 is equals to 8H plus 2WH. Now we substitute with the WH, which we get from here. Okay, now we'll get this equation.
So here is a general visualization on how the equations will look like in a diagram. So this is the first one of the volume for the equation of 4WH equals to 16 meter cube. So moving on to the next diagram, as you can see here, this is the diagram for the base area. Now remember that there's only one base area, as this is a open top container. Now the first two equal sides we will use to equate it as 4H, 4 being the length, H being our height. Moving on, we will look at the area for the remaining two sides that we have not calculated yet, which is the width times the height.
Now it's the cost. So you have to substitute the RMA and RM2, and also the H, which we get from here. Okay, here's the total. Here's the final equation, which we times the 8 with the 4 will be 32, and the total 8 times 2 will be the 16. So here is the final equation of the cost.
Alright, now let's continue with this question. So we have the cost function right here, which is 32W plus 64 over W plus 16. But we have a lot of variables here. So what we're going to try to do is to find the value of H and W first. Now first of all, we're just going to differentiate our function right here. So once we differentiate this, we will get from 32W, we will take the power 1 and times it in front, which will be 32. The power of -1, we times it in front, which will be 64. And we also must minus 1 for the power. So this will be -2, and this will be -0. So we don't write the W in front anymore. And after that, since 16 doesn't have any variable of W, once you times the front with 0, it will just be nothing. Now, after that, we must find a stationary point to exactly pinpoint our value of W at that point. So let's say for this equation, we will shift the derivative into 0. So 0 will be our stationary point, alright? And once we have this at 0, we can shift this around to find the exact point of W. So let's take this part and shift it to the left-hand side. What we'll get is 64 over W squared equals to 32. And after that, we're going to try to make W squared into just a single W. So what we're going to do is have 64 divided by 32 right here. And we will shift the power square to the right-hand side. So what we will finally get is W equals to square root of 2. After that, once we have the value of W, we're going to substitute it back into one of these equations. The equation we choose is H equals to 4 over W. Now when we substitute it back, we will get the value of H equals to 4 over square root of 2.
Next step, we need to find if the cost is maximum or minimum. So we have to do second derivative. To do second derivative, we need to derive the first derivative, which is this equation. So we differentiate 32 minus 64 w to the power of negative 2. And for 32, we don't have any variable of w, so it is times 0, which makes 32 the whole thing 0. And we take negative 2 and times it by negative 64, which gives us a total value of 128 w to the power of negative 3.
Now I'm going to add some additional information so that we can understand this question better. When we do mathematics questions, we usually deal with two-dimensional questions and we draw an fx graph, which is this one on the left side. But now we have a three-dimensional shape, which is the rectangular container. And the graph would look something like this. One fx graph, two fx graph, and then they share the same y-axis. If you visualize it, it would look something like this. So for our question, we have this equation. Cost equals to 32w plus 64 over w plus 16. So to simply put it, the cost will be our fx or our y value, and the w will be our x value. So as previously explained, we differentiate it and set the value as 0. And why we do that is because after we differentiate it, we get our gradient. And if we set the gradient as 0, it means it is a horizontal line. And the point sits on the horizontal line. Therefore, we can find the w value and then find the h value. After we find our stationary point, we don't exactly know where the stationary point is located at. So to find the maximum or minimum, as previously discussed, we need to get the second derivative. If the second derivative is greater than 0, which is a positive number, it'll be a minimum point, which looks something like this. And if the second derivative is lesser than 0, it'll look something like this, because it will be a maximum point.
Wow!
And to find the value of the second derivative, we can substitute w equals to square root of 2 into this equation. And after substituting w equals to square root of 2, we get a value of 45.25. And this value is greater than 0, and it is positive, so it means that the cost is minimum. So the overall dimensions for L is fixed, which is 4, w equals to square root of 2, and h equals to 4 over the square root of 2. Moving on to the next question, we need to calculate the minimum cost to manufacture the rectangular container. So in the previous question, we had the equation of cost. So we just have to substitute w equals to square root of 2 into this equation to find the total cost. And after substituting, our total cost to manufacture the container is 106.51 cents.
Moving on to the third part of the question, I will discuss briefly how this type of mathematical optimization is important in the industrial design, packaging, or manufacturing cost control. This mathematical optimization is important in the storing industry is because that it minimizes the production cost and maximizes the efficiency. Why do I say that? It's because that when storing industries keep the dimensions and material costs to the minimum, the production of the containers would not need extra raw materials, which leads to a reduce in material waste. As when extra raw materials are used, the cost increase, thus the industry can maximize the efficiency. Why do I say that? It's because a smaller space is only needed to store the containers that are produced. For some example, are these shipping containers. More containers can be delivered in these ships as the containers are kept to a minimal size. This also improves the profitability and increases the added value of these storing industries. This is the end of our presentation. Thank you, Miss.
Thank you.